幸邀请到演讲嘉宾，台湾西门子董事长、总裁暨执行长张和系先生。张和系先生将为我们带来题为“从热潮到产业落地效应：西门子的数位双生及工业 AI 的精彩分享”。For our next session, it is our great honor to welcome our speaker, Mr. Frank Grunert, Chairman, President, and CEO of Siemens Taiwan. Mr. Frank Grunert will share his insights titled, From Hype to Impact, Siemens Digital Twins and Industrial AI. Ladies and gentlemen, please welcome Mr. Frank Grunert.
Hi, good afternoon. Dacia. What you have just seen was not a science fiction movie. This is in fact what happens when digital twins and industrial AI come together. And this is what Siemens is doing. You saw a rover landing on Mars. And actually that was already in 2012. And NASA used a Siemens digital twin at that time already to make 8,000 different simulations in order to land it there for the first time. But you also saw a fusion reactor. I talk about this a little bit in some while, about humanoids. And also some day-to-day goods. And Yvonne, I'm a little bit thirsty. Maybe you can give me something to drink. Thanks a lot. Yes. So that's a day-to-day good. That's a simple can of Pepsi. Right? And okay, we shake it a little bit. It's good. A little bit of sugar. This can, as a product, was released already in 1963 by Pepsi. And since then, hundreds of engineers have spent thousands of hours to optimize it. And you would not have thought that this is something which can be optimized even further after 63 years already on the market. But now, with digital twins and industrial AI, we can also put this can on the next level, like the beer and, of course, Coca-Cola. I don't want to forget about Coca-Cola. So, for the last couple of years, we all have been very fascinated about AI and what it can do for us. It can write emails for us. It can create pictures for us. It can write code for us. A lot of us are using it to write code. But when we look at the real impact, when we want to move AI into a real impact in the real world, we need to talk about the industrial sector. And in the industry, we are asking quite some different questions. We ask, how can I use AI to increase my productivity? How can I use AI to improve my energy efficiency? How can I use AI to accelerate my innovation? Because answering these questions means that we need to also look at physics behind. We need to look at engineering. We need to look at data. We need to look at domain know-how. And this is where Siemens comes in. So for us in Siemens, it's pretty clear that there are three basic technologies which combined will help us to have AI make a real-world impact. Technology number one are digital twins. And digital twins are there to simulate and optimize in the virtual world anything we want then to have in the real world. The second technology is software-defined automation, which is really, really crucial, and we are moving into this now in order to take inertia out of the system, in order to speed up changing our production environments. The third technology, of course, is industrial AI. And together combined, these three technologies really make them the impact. Taiwan is looking at another golden decade. And you know, here at Computex and listening to Jensen Huang and seeing all the people of the trillion-dollar dinner and how well the companies are developing is one part of the story. It's the AI infrastructure build-out. But the real opportunity for Taiwan is ahead of us, which is not only building AI infrastructure, but using AI in order to build things more efficient, faster. And Taiwan is very well prepared for this because Taiwan is one of the epicenters of manufacturing globally, not only in the semiconductor and electronics space. And Siemens is here in Taiwan to support. But if we want to move AI to industrial AI, we need to be very clear that in this sphere, in this process, there is no room for error. So in industrial AI environments, the AI cannot just be mostly right, or AI cannot just guess outcomes, because mostly right could mean that we have an accident in the production environment, could mean that a machine is down, could mean that we lose millions, like in the case of big semiconductor companies when the fab is standing still. Industrial AI has to rely on physics, has to rely on real engineering data, has to rely on real process domain know-how. And this is exactly where Siemens comes into the picture. Recently, Siemens released the Eigen engineering agent, which is moving industrial AI to agentic AI. And so in order to explain to you what that agent does, just imagine you're an automation engineer in a factory and you are running a complex production line setup comprising of hundreds of PLCs. And let's just imagine this is in a critical product line, like for automotive, for example, where you have very strict standards and a lot of documentation requirements. And you need to update the production line with the latest optimization input, or you need to update the production line with a new product. And this means actually that you have to go through all this documentation which is there for that specific product. You have to access all the PLCs on these machines. You have to pre-program the new configuration for the production line, and then you have to update these PLCs. It's very tedious, a big amount of bulk work. The engineering agent is exactly there to change that, and not only to support you doing it, but to complete the task for you. So the engineering agent is not only designing what should be done, but also implementing and validating again and again and again until the result fits to what has been designed. And then the engineering agent is deploying this inside our Siemens TIA portal, deploying this to the PLC at the machine. This is true industrial agentic AI, and this is available and released. Siemens and NVIDIA have quite some long partnership story, and recently NVIDIA and Siemens have partnered to move industrial AI towards the industrial AI, what we call industrial AI operating system. In industrial AI, we talk about the applications which you use in order to improve certain production steps. An industrial AI operating system, in fact, is like a fabric in your factory, connecting all the different assets in your factory, connecting not only the different applications and seamlessly creating a flow, a workflow, and optimizing that workflow, but also connecting all the data around it. And for this partnership, Siemens brings a lot of engineering know-how and a lot of manufacturing know-how, and of course, our portfolio to the table. And NVIDIA is bringing their competence when it comes to AI compute power and also when it comes to the Omniverse, in order to create really realistic digital twins which can serve as optimization environments for industrial process optimizations. And we are bringing this industrial AI operating system to life now in our electronics manufacturing facility in Erlangen in Germany, where NVIDIA and Siemens are together creating the first ever global, the first ever fully AI controlled factory. And as Jensen Huang put it, Siemens is helping NVIDIA to move faster, and then NVIDIA can produce compute faster to help Siemens even become faster. It is working like a flywheel. A lot of talk has been about data centers, and in fact, data centers are now AI factories. And Jensen Huang said it very clearly. It's about token per watt. Token per watt optimization means that we have to optimize the AI factory end to end, from distribution to cooling to compute, including all the building technologies. Hardware needs to be optimized and seamlessly working together, but also controlled by an integrated management system, which is optimizing all the different parts in a digital twin and then deploying the new parameter settings to the machines. But it's not only about token per watt, it's also about fastest time to the first token. And here Siemens is one of the partners of NVIDIA when it comes now to the Vera Rubin DSX reference design. We have released our Vera Rubin DSX reference design this Monday, this week, helping data center operators to touch a design which is ready out of the drawer, already fully optimized throughout the full supply chain, and minimizing the time to first token significantly. Foxconn is also utilizing this partnership already between NVIDIA and Siemens. Here in the video, you see a digital twin which was created for Foxconn to help them ramp up the AI server production for one of their facilities significantly, allowing the Foxconn engineers not only to simulate the utility consumption and the utility ways in the factory, but also where the machines are, training the robots in the digital twin, and also optimizing energy consumption, all in that digital twin. And now comes the picture from the future, the fusion energy. Imagine a world where energy is free and we have it in abundance, and fusion energy actually is exactly the answer for that. I just give you one example here. This is a spin-off from MIT, Commonwealth Fusion Systems, and together with Siemens, they are working on building a fusion reactor, a spark reactor, and they are using a Siemens digital twin for that. And this digital twin is highly photorealistic, it's highly comprehensive. It simulates 2 million discrete parts, 2 million discrete parts, helping CFS to minimize years of physical experimentation they had to use before the digital twin in order to optimize the different parts of the reactor and condense that down into weeks or months of virtual simulation. It's a great example how this industrial AI digital twin technology is now speeding up the innovation in such kind of sectors. Another example is the rollout of humanoid robots, and a lot of talk has been about that. So in normal automation, we often face the problem that automation environments are very rigid. So once you can start with a white piece of paper and you optimize your factory from the start, it's very easy to optimize everything to the maximum. But once you have a brownfield situation, it's better to have something more flexible. And here humanoids come into play. Humanoids help us to work alongside with other robots. And we are partnering here with a UK company called Humanoid. And in our factory in Erlangen, electronics equipment manufacturing facility, we have now completed the first successful pilot where we use our Siemens C-Navigate ANS Plus software to let a humanoid work in a live production environment autonomously, alongside around 30 AMRs and alongside the factory workers on the floor. Another example, coming back to my can of Pepsi just now, is our digital twin composer, which we released recently, which is based and interfacing to the Siemens TIA portal and creating automatically a digital twin. Digital twins are actually a kind of bottleneck at the moment because it takes a lot of time and effort to create one. And this problem we are solving now with the Siemens Digital Twin Composer. Pepsi has implemented this together with us for this facility you can see here, achieving tremendous production efficiency gains. So for example, 90% of all issues they were able to already identify before they have physically implemented the facility. This is pure money. They are now moving from slideware to reality. They have increased the throughput in that facility compared to other facilities they have by 20% because they could optimize everything in the digital twin, the whole production workflow. And they were able to reduce their capex by 15% to use less space, for example, giving them pure value just by implementing the software. I talked about software-defined automation in the intro, and I want to give you quickly an example here from Audi, who have implemented the Siemens virtual PLC environment in one of their facilities in Germany, separating the hardware from the software. So at the moment, in a lot of facilities on the PLC, we have the hardware and the software together. Separating it gives us a huge, tremendous speed gain. And the centralization of the software in the virtual PLC also helps us to take out inertia in the system, be able to deploy code faster to machines in this facility. So once we are changing the production process, and also is helping us to make the whole facility more cyber secure because you can centrally update and upgrade all the production machines in that virtual PLC system. By the way, Audi is now running this facility at much faster speeds than the other facilities. Using a virtual PLC in that case reduced their cycle time by 50%. Now, a lot of people ask me, hey, Frank, these are very nice examples. How do I get started? Because I have a normal factory, how can I get started? First, you need to understand that this is not just about digital twins and AI and a machine. It's about the whole infrastructure around it. So in production, we need sensors attached to the machine. We need connectivity, low latency, high availability, industrial grade connectivity. We must not lose data on the way. We need a data storage layer, industrial grade, industrial servers, where our AI and digital twins can access the data and where they can work on and optimize. And then we can optimize and put the result back to the hardware. But if we want to do that automatically, we also need an integration layer. We need APIs, service buses, and if we want to enhance the functionality, we also need applications. So then we have actually, and this is a very, very basic AI infrastructure we need for applying industrial AI. But this is exactly where Siemens comes into play. And this is also why I said Taiwan has another golden decade ahead of themselves, because Taiwan's companies are actually device manufacturers of a lot of these devices, which you see in the green areas here on that slide. So we also should not only use this technology to get rich, right? Looking at the market caps of all these companies, we should use it for something better, for something good. Talking about sustainability. Combining the real and the digital worlds is helping us around the globe, not only in Taiwan, to handle scarcities in water, electricity, and land in a better way. Jie Yuan Jen Tan. And to achieve more with less. A recent study by Boston Consulting Group and by Accenture found that the global rollout of digital twin and industrial AI technologies can save up to 12.8 gigatons of greenhouse gas emissions globally, which is a lot. We are emitting globally around 60 gigatons of greenhouse gas emissions. So this would be around 20% we could avoid, which is a lot. And in the end, also, of course, this translates into money because we use less material, we use less electricity, and it increases profitability. Doing something good for your wallet and doing something good for the planet. Now, I talked now a lot about the big picture, but what are we actually doing here in Taiwan? And I want to spend a couple of minutes to talk about this, because Taiwan's industrial landscape is really an early adopter when it comes to adopting industrial AI technologies, and Siemens is a partner here for the Taiwan manufacturing landscape. One example I brought with me is in Taoyuan, where Quanta is designing and setting up the production facility now for a automotive electronic controller, which they want to use and which is a decisive part when it comes to autonomous driving. So also a very good market for that. And they do this together with Techman Robot. And Siemens is helping Techman and Quanta to create a digital twin where they can simulate not only the production, but also in a digital thread, the whole process from design to material inspection to doing the production, the manufacturing itself, to quality inspection, to packaging, because Quanta has to deliver this according to the ITFA 16949 standard, which is a very high standard when it comes to automotive industry. It's in the end, it's about human safety. And this digital thread and digital twin is helping Quanta to get the very extensive documentation right from the start. Another example is Play Nitride, one of the leading micro LED producers globally. They are in Hsinchu, and they are using Siemens digital twins in order to increase the efficiency of their manufacturing significantly and reducing material waste. They use, I put some product names here for you. So SimCenter is actually our main digital twin software, MCT Simatic, Machine Simulator, and Tech CPUs. But it's also the more traditional industries which are benefiting. Like here, I brought an example for me from Taichung. Goodway and Hotta Industries in Taichung are two machine builders, and they have deployed our Siemens adaptive control and monitoring technology. And in machine building, the tool, once you are starting your production process, it's getting degraded over time. So the more parts you make, the more the tool gets degraded and the more out of bounds you might come with the quality. And that is an AI-driven smart learning application which is continuously monitoring the usage of the tool. And then once the tool is starting to degrade, adjusting the machining parameters so the first part has the same quality as the last part, helping to reduce machine downtimes and helping also to reduce tool cost and improving the productivity of machine builders by 20% just by deploying that software in the machines. And going even more traditional, talking about steel making, China Steel Corporation in Kaohsiung, we are working very closely with them because we can make big impacts there when it comes to digital twin and AI technology. And they are using a SimCenter. This is just one of the examples we have with them, a SimCenter digital twin to simulate the commissioning of their slab casting line, of one of their slab casting lines, to optimize this. So, and they were able to reduce the downtime. So once they have to change the production for slab casting, they need to redo the commissioning, and they were able to reduce that downtime from 65 to 38 days. 27 days less downtime for such a huge facility with this huge capex investment is a lot of money. So a very significant increase in productivity achieved with Siemens digital twin technology. And now coming back to semiconductors, maybe some of you have read it. Recently, Merck has incorporated their semiconductor solution megasite in Kaohsiung. And when they planned the whole facility, they already engaged with us using Siemens digital twin plant simulation software in order to optimize certain processes in that facility. And so, for example, they are doing the virtual commissioning and testing in the digital twin before they apply it in the real world, and they are able to reduce trial run times compared to comparable facilities in other places globally by 50%. So now, how can nations and companies stay competitive in the age of AI? And maybe I want to conclude with three little advices. Advice number one, it is important not only to look at software, it's also important to look at hardware. As I showed with my ecosystem chart, we need to have both. If you don't have the hardware ready, you cannot deploy industrial AI. It is also important to understand that nobody can do it alone. We can only do it in partnerships and in ecosystems. So Siemens is collaborating with a lot of companies, Microsoft, Google, for example, for cloud storage, NVIDIA. I just gave you some examples. but it's also beyond the business space. It's universities, research institutions. We all need to work together in order to accelerate the deployment of industrial AI. And of course, we need to be fast. Learn, adapt, have a continuous improvement cycle in your company is crucial in order to be successful. So I think it became clear. So consumer AI is making the headlines, right? ChatGPT. But I think the real impact is with industrial AI. So to conclude, and coming back to my little buddy here, the Pepsi, who would have thought that this can still be optimized? And it can. So for me, I'm very curious now, learning this about the future, what comes next, how we can use AI to make a real impact and to improve the reality and make the world a better place. Thank you very much for your attention.